In this video, we will be continuing on from the last episode on types of matter, where we established what the three different types of mixtures were. At the end, we talked about what mixtures were and gave an example of a mixture being dirt water. But actually, we're able to classify them further into different types. Mixtures can either be homogeneous or heterogeneous. The way in which we classify the mixtures is based on the uniformity of its composition, and we will delve deeper into what this exactly means later. So what we know so far is that mixtures either contain multiple different compounds, different states of a compound, or a combination of elements and compounds. First, we'll look at a homogeneous mixture. Now, if a mixture is homogeneous, this means that the mixture has a uniform distribution. An important thing to note for homogeneous mixtures is that the components must also be in the same phase. Now, an example of a homogeneous mixture is salt water, in which the salt has now dissolved inside of the water, or another example can be air, which, as we previously mentioned, is a concoction of a variety of different gases. If we look on the diagram on the right-hand side, this provides us with a depiction of what the structure of a homogeneous mixture would look like at the microscopic level. As we can tell, regardless of where we take the sample, we would not be able to select a unit which is different from another one. There's an even distribution of the dark blue and the light blue circles. Now, in contrast, we can have a look at this other classification, which is the heterogeneous mixture. A heterogeneous mixture has a non-uniform distribution and may have components which are in different phases. Now, an example of this which we will look at later is ice water, or we can have soda with ice cubes. Looking at the diagram on the right hand side, we see that the light blue and the dark blue dots are neither evenly spaced between one another, nor are they distributed in an alternating pattern. This means that no matter where we grab the snapshot from, we should have a unit which looks slightly different from the other. Let's look at an example of a mixture ice in water. We know that ice is just solid water which has the chemical formula H2O, but if we remember, one of the definitions of a homogeneous mixture is that the components of it must be in the same phase. Now, in this case, we have a different phase, ice and water, and thus this must be considered a heterogeneous mixture.